Hello. Hello. Shubham Aryan, 2 questions. No worries at all. We will see all 4 of them. Firstly, if the folks have joined in, can you please smash that like baby to 15 likes? That would be super great. And yeah, just let me know कि हो रहा है. शिवम नेगी बहुत हो गया. Aryan lot आओ. Hello guys. That's a good one. Vinay Kumar, bro, hi MS Darshan, hi Shubham Aryan. 2 questions, no worries. 2 questions, no worries. I can't see. In today's question number 3 was a bit tricky. Question number 4 was not that hard, but yeah, matlab, it was a mix of medium to hard. It was scored as 8. I know. Don't get me on this, but yeah, it was. I'll consider. I'll consider both of them as question 3 and question 4 equally, because question 3 was more of key. It's like if you got it, you got it. It's easy. In question 4, the implementation is hard, but the logic is more or less easy if you know bit masking stuff, simple or operations. But yeah, before that, can we please smash that like baby? Yeah, you know the ritual, right? Smashing that like baby. 20 likes. Let's reach it. You folks are, see, if you have solved either 1 question or 2, no worries. We will see all 4 of them very easily. Ekansh, hello bhaiya, hope you are really well. Just आपकी दुआ से एकांश. Ritik, hello Harsha, hello CK, hello Gautam, Dipanshu, Adarsh, hey bro, Aditya, who done only, no worries. See, in today's one, actually question number 3 and 4 were actually hard, so no worries on that part. You'll see all 4 of them. Shout out to me, Dipanshu. Great. Learn with Pulkit. Hello bhaiya. Gautam, is question 3 based on heaps? It can be done on heaps, but then the complexity will be O of n log n into n, which is actually more. So we can't do it with heaps, although the proper straightforward intuition will actually be okay. We just want to get the maximum number, we'll get maximum number out, and then we'll push it back. We'll keep on going it on the n. So n log n for that, n again going on to those n elements, and then again n. So it will be actually more in complexity. So we have to go other way, that the complexity we should not go in, because solution it can be done in heaps, the priority to the heaps and stuff, but we have to find some other way as well, which is actually more easy. Sorry, which is actually less in complexity, right? Hello Royal Chaudhary, hello Kushagra, Adarsh, hello, hey bro, hey Janam. शिवम, टट्टी करते हुए स्ट्रीम देखने का घमंड है. ऋतिक, by weekly was much easy. Yeah, it usually happens. No, we can't generalize anything. It can be anything. Maybe it's easy, maybe it's hard. We'll quickly start with the problem statements in just 1 minute. Hey Aditya, hello bro, hi bro. 4 was really hard to me. I will not say it was hard. A bit implementation is hard, but the logic is kind of easy. It's a simple DFS. That's it. We'll see. Like 4th is actually very easy. I think the 3rd was much harder, because to understand 3rd and why it is actually correct is actually a bit tricky part. 4th is very straightforward. If you know it, you know it. But 3rd, to know actually why it is true is actually very tricky. So that's the reason, like from my perspective, 4th was a bit easy, 3rd was a bit harder than 4th, what I thought. It can be different for you depending upon what you know. If you are good with bit masking and stuff, if you know, okay, the standard and or and XOR operation, if you have watched our EP with bit masking and all that, so it would be easy to understand. But yeah, no worries, you will see actually everything. I have done 1, 2 and 3. That's great. Hi bhaiya, saal baad contest diya, motivation gayi sari. No worries, it will come in again. Hello bhaiya, so lag gaye. We're really waiting for the 3rd question. Solution, cool. Let's quickly jump on to question number 1. Standard ritual, we solve all 4 questions. We'll go one by one to all the 4 questions. Quickly jumping on, but before that, can you please smash that like to 30 likes? We'll quickly jump. See, 1st and 2nd are more or less. Thus, 2nd is also a bit good. So we'll also see the question number 2. But yeah, primarily focus on question number 3 and question number 4. First one is very standard and very easy. Just a straightforward implementation of your string stream or any kind of thing which you use for your bifurcating your string on the basis of the delimiters. It just says that split a string by a separator. You know, I know, if you have a standard code written for it, I use string stream to actually separate my strings on the basis of a separator. So it just says, okay, I have a string words and I get it as a separator and split each word by a separator. For example, I have this particular string of list of strings. It is one string, it is another string, it is another string. I have to separate this string itself by this separator. So it will become a 1, a 2, a 3. Again, I will just separate it. It will become 4, it will become a 5, and then it will become a 6. So it's just nothing but input this string, separate this string on the basis of this separator, return strings, and keep on pushing those strings ultimately in your answer vector of strings. A simple, very, see, it's nothing much new. If you know how to code it, good. If you don't, just simply search on Google how to basically how to separate string on the basis of a separator or a delimiter. If you had just searched the same thing for your language, something would have come up. Just copy paste that here and it will be simply good to go. For me, I usually use string stream, which means I went on to all the strings of that word which is given, which means for this string S, my string S is this particular string. It is my string S. Now for the string S, I will push this string S in my string stream. So I just push this string S in my string stream. String stream will actually make sure it will just parse this string as a basis of, okay, parse this string and just keep on going in this string. Now, as my string stream, so my string stream has an input as a string which I have passed in from the words array, right? It is just one string. Now my string stream, unless my string stream is good, what I will keep on doing is I will just grab a substring on the basis of a delimiter. So I initialized a substring because I want to grab a substring in my string stream. So I just grabbed a substring, and that substring to grab on the basis of a separator in this string stream. Just get a first substring whatsoever you have. It will just get me the substring separated by this separator. If it is actually a string, if it's not empty, I simply push back in my answer that substring, and I will just keep on going on until my string stream is actually having something with it which it can actually parse in again and again. So I will just simply go and parse my string stream until I have any of the substring left which can be separated by a delimiter, and as soon as I will get any substring, I'll just have a check. If its size is good, I simply push that in my answer and will simply return that particular answer. I usually use string stream to actually parse my string and separate that by a separator. You can use anything whatsoever you want, but it is a standard code which I follow. I have put this code in my notes. You can also put that. No worries, it is only up to you. Cool. I hope that everything is nice. Audio, video, everything is nice. Quickly jumping on to question number 2. We will see question number 2. That is actually again a very standard concept of just a variation. Let's quickly read the chat very quick, just a 1-minute chat read. But yeah, before that, can we please smash that like to 40 likes? That would be super great. I have an issue. Hi bro was really hard to me. No worries, I have issue in third. Yeah, we have, everyone has. Bhaiya, how much time it takes so that we can solve the 3 questions? Last 6-7 weekly contest, 2 questions ही हो रहे हैं. It is never on if we can solve the question number 3 or not. It's always on कि ठीक है, question number 3 कितना hard है, कितना easy है. How easy the question number 3 is. For yesterday, question number 3 and 4 both were very easy. Question number 3 here was actually a bit tricky. Question number 4 was easy, not hard. That's it. Hi भैया, साल बाद contest दिया. Hello भैया, आज तो लग गए. Really waiting for third question. Solution. How much time minutes you took to solve all 4? I did not solve all 4. For question number 3, I got the intuition. I could not solve it properly, and I started very late, so I could solve 1, 2, and 4, not third. A third was pata nahi how come its solution came out to be pretty easy. I was applying something very complex. Third, say start karna please. See, we Rasanpreet, we usually go in the order 1, 2, 3, 4, but no worries, we'll just see everything. रात को rating बढ़ाओ सुबह घटाओ. That's true. Yashwant, hello bro, hello. Bhaiya, fourth was showing TLE with map and showing accepted with unordered map. What I can do? If you can use unordered map, you should always use unordered map. Why to use map? You should not. Cool. Aditya was third greedy. I have sorted and was counting from the reverse. as a kuch logic se hoga kya? Yeah, true. Third was greedy for sure. The intuition was properly saying it's a greedy problem. But it's just that how you solve that greedily is a matter of fact. Cool. Tech up 2 by 4. No worries, tech up. We are here. Satish, I solved only one. No worries, Satish. We'll see question number 2, 3, 4. Very briefly. I solved 1 and 2. No worries. Leetcode ka problem of the day. Kab upload karoge after this contest? Probably because I woke up. I started reading the problem, tried to make that video, but then it just went down, and then I started the contest. It's so much in so less time, right? Let's quickly jump on question number 2. Largest element in an array after merge operations. Now it just says that simply I have a zero index array as nums. But yeah, before that, can we please smash that like baby to 45 likes? Just 3 more. Cool. Zero index integer array nums consisting of positive integers. You can do the following operation on the array any number of times. Repeat that word, any number of times. Now coming back to what I can do, I can choose an integer I, and if I choose an integer I, what I can do is, if my nums of I is less than equal to nums of I plus 1, I can replace my nums of I plus 1 with the sum of nums of I plus nums of I plus 1, right? So it will be something like this. Okay, I have an element, let's say 3. I have just next element is, let's say 6. What I can do is, provided this element 6 is more than 3, I can replace this number, nums of I plus 1 with what? With the sum of these two, which means I can replace this number by a 9, and for sure this 3 will be gone. But I can apply this operation only when it is the just adjacent element, which means the just previous element, and for sure when the element is gone, so the next previous element will become the previous element for him. So that is a concept which I can get to know from this particular two lines. I will have a number, I can just look at the previous number. If it is small, I will just add that value. Let's say it is A, it is B, right? B is big. Let's say B is big. So I can add my A and B. It will become a B plus A. And for sure, this A will be gone. Let's say I have a C here. So a C will come just beside it. Now again, the same process, it can go on and keep on repeating, because if my B plus A, if it is more than C, for sure this C can add up in B plus A. It will become a B plus A plus C, and this C will simply go on. That is something I can get to know from these two lines. Cool. I have to return the largest element that I can possibly obtain in the final array, which means you know how the element will keep on becoming bigger and bigger by simply adding it with the previous element, right? If the element which is previous, if it's more, sorry, if it is less, it will just simply add on to the next element, and it will make it bigger, right? So I know it will add in here and it will make it bigger. How big I can make any element, that is my task. Now, as we read the question, okay, we have some idea of what is happening in the back of our mind, but we will see it more clearly by the example itself. 2, 3, 7, 9, and 3. Now, make sure you don't look at the explanation. It is waste. Try to make by the logic you have read above, try to make by yourself. Now, what you can do is you can simply start off with any number, right? What you saw, as I have standardly told of, just go and strike the mid anywhere. Okay, I want to make any number as big. What if I know it is 2, it is 3? Because I'm starting from the very start. 2, it is 3. Okay, I'll simply add a 2 in my 3. It will become 5. Great. I'll simply add here. Oh, it will become a 12. Great. And see, when I'm erasing that element is gone. Oh, it's 12, it's 9. Oh, now I cannot add it. Now I cannot add it here. So by me I cannot add it here also. So by me, the last state would look something like this. But I know the answer is 21. But my answer is maximum 12. What I did wrong? You saw what I did wrong. I did something wrong as 2, 3, 7. I know as I was adding my left elements as, just a second. My neighbors just shout at me because I just disturb their sleep. So I will close the window every time I will do a live stream. They are just fed up from me. I will be kicked out of the society soon, very soon. Coming back to what you were saying. So one thing we got to know, one thing for sure is, I have a 2, I have a 3, right? So for sure, when I was adding from the left, so I was making the left part bigger. When I was adding from the left, because I was moving from left to right, I was making the left part bigger. But ultimately my concern was that my right part should be bigger than the left part. Oh, so what I can do is I can apply the same operation from the right side so that my right part will keep on becoming bigger and bigger and will ultimately help me out, right? What I can do is now, as I was doing operation from the left, I'll start to do the same operation on the right itself, which means I will just ask him, hey bro, are you bigger? Nahin. Cool, no worries bro. For you up till so far the sum is 3. Okay, hey bro, are you bigger? Yeah bro, I am bigger. Cool, bro, add this to me. Cool, now it will become a 16. Now for sure this thing is gone. Now it is adjacent. Hey bro, are you bigger? Yeah bro, I am bigger. Okay, cool. Simply make it as 19. Hey bro, are you bigger? Yeah bro, I am bigger. 19 is bigger than 2. For sure bro, add a simple 21. Oh, that is how I can simply get the highest value. Now, you will say, Aryan, that seems correct. So what I can do is I can simply go on what we were doing from the start. I'll simply go on and do from the end itself, which means I'll go and simply do from the end and I'll simply try to make everything bigger, as big as possible. Aryan, what if the next number would have been 23? Then okay, cool, no worries. If the next number is 23, you know one thing for sure, that the maximum you have obtained so far by this range you have obtained so far is 21. Okay, cool. Just simply update your answer with the maximum you have obtained so far is 21 and simply keep on moving. Okay, now the sum again has reverted to 0. So now simply you started again from 23. Now you simply go on and ask the back, hey bro, what are you? Let's say the last number is 19. Oh, simply it is smaller than me. Okay, so I can simply add it. So simply add this number. Now by this I can simply go on until it is less. Then again, if something comes very big, let's say here comes 86, then for sure again I have to stop my stuff and again keep on going left. So by this I can get to know that okay, it is the maximum I can find. It is the maximum I can find. It is nothing but kind of, if you are going from the back, we are finding the sub-array sum. We are finding the sub-array sum, provided that the sum which is building at that moment, it should be more than the previous number. Which means here you saw one thing. I had the element as 2, 3, 7 and 9. So the sum which is being formed, here I added this, it became a 16. So this 16 is more than 3. Let's say if it had been let's say 11, still I would have added this in my number, because for sure I am building my sum from the right to left. It will just keep on becoming bigger and bigger, and that will help me make sure that I can simply add my previous numbers to it. That is how. Just it's a simple greedy, moving in from left and making the sum, right sum as big as possible, so that the previous number, it can simply add up to me. Now I will simply add this number up to me and I'll simply keep on increasing it, and that's how I can simply find the maximum sum every range can provide me. Okay, if this can provide me the maximum sum as 21, I'll update my answer. Okay, right now the maximum sum was 3. Cool, update the maximum number, it is 21 now. I'll simply go and start from here itself. Again, it will just go and find what is the maximum it can get, update the answer and simply keep on going. So it is kind of a range sub-array sum I am finding, but this is on the basis of what? On the basis of the current sum which I am updating at every moment. That is how you can solve this problem. Cool. Let's quickly see the code. It's very easy, very short. I have simply my answer, which is the global answer, which is the maximum I can find out. Right. Cool. Let's quickly see this. But yeah, answer. It is nothing but the global answer which you can find out. It is the current sum. As I showed you, I am going from right to left. So at that moment, when I started, I am finding the current sum. Current sum should be more than equal to the previous element, right? So I will just simply go on. Firstly, as I encounter any element, I'll just simply update my current sum with that number's value, because I know, okay, my current sum will actually add this number up. Now, for sure, I need to update my answer. So I'll keep on updating my answer at every moment of time. Okay, what is the maximum current sum which you can give me? Now, you know the current sum is nothing but the sum of this particular, because you know the current sum is being updated by the sum of previous number also. Current sum, let's say here, okay, let's make it again, 2 3 7 9. The current sum here is 9. As it moves on to here, the current sum will become a 16. As it moves here, the current sum will become a 19. As it moves to here, the current sum will become a 21. And this current sum is being updated. Okay, as it was here, the current sum is 9. When it is being encountered, the 7 is being encountered, I will ask him, is the 7 less than my current sum, less than equal to my current sum? If it is the case, I can simply add this number in my current sum, which means I will add it next time. That is how. So I just simply go and ask him, hey bro, is my current sum less than my nums of I minus 1? If it is the case, then simply make it 0, because if my nums of I minus 1 is less than equal to my current sum, then for sure I can add this nums of I minus 1 next time in my current sum, because as a loop goes in, next time I'll simply, because as you know, I is simply reducing, so next time in current sum, this nums of I minus 1 will be added. So if it is not the case, which means if my current sum is less than my nums of I minus 1, simply, you know one thing, simply reduce your current sum to 0, because you know now your array, now it is done. Now you saw the current sum was actually 21 here, but the I minus 1 was actually 23. It is more. So simply reduce your current sum to 0, because next time it will simply start from this 23 itself. So the current sum will actually become 23, not actually adding this number. So I know I have to bifurcate, which means I am kinding of making my sub arrays like this. That's how I can simply go and make my current sum as 0 again, which means my current sum will again keep on adding my nums of I, and by this I can simply return my answer, which is the maximum current sum I can update at any point of time. That is how I can simply solve it. Okay, what's the maximum number I can make out by simply, because I know it's a sub array which I can make. What's the maximum number I can make? That will be this current sum, and that I can simply return it because it's a maximum number I can make in the entire array so far. Cool. I hope that you guys got it. Can we please smash? We'll quickly jump on to question number 3, but before that, can we please smash that like baby to 50 likes? Just 3 more. That would be super great. Let's quickly start from. Let's quickly read the chat out. But yeah, before that, can we please smash that like baby to 55 likes? Just 3 more. That would be super great. Is 3 is third? 1 minute. I solved only 1. I solved 1 and 2. Cool. No worries. Leetcode to problem of the day कब upload करोगे? That is done. 4th का idea नहीं आया. No worries. Is third? Can we use? We can use binary search on answer. Yep, you can use. On Aryan Mittal question 2, I used stack to solve the problem. Yeah, you can use it for sure. Simply pushing that element to stack. See, it is nothing but going from end to start. In stack also, you just have last and first out. You can use anything whatsoever you want, right? It's just that what easily strikes you. Earlier, I started from the starting itself of the array. Then I thought, okay, starting was not good. Let's start from the end itself. So I started from the end itself. With the end as I am starting out, I got to know, okay, I will try to make everything greedily as big as possible. Oh, I try to make everything as big as possible, because I know if last number is being added, it will just keep on increasing and keep on increasing a number. It will actually help me to add a previous number, right? That's how. Simply, you can use a stack also. No worries. It's just thinking of it as a vector or a stack. Anything. Vector, stack, DQ, all are same. Then start from the last. Sorting would change the order, which would be wrong. Abhinav, should we sort the array first? Sorting can't be done because I'm concerned about I and I plus 1. Order needs to be maintained, right? Same approach, solved first two problems in 20 minutes. Cool. MS Darshan, wait, it's same thing now, since you may have performed operations on peak and even he is doing it from the last. Yep. Oh, right. Mono stack questions. How many questions did you guys solve? Your approach 2 is really nice. I solved using DP. How can you that happens, Prajwal. We also sleep and wake up, but yeah, let's quickly jump to question number 3. Actually, it's a good question. Everything will actually speak out of many intuitions in this problem. Cool. I was about to make the notes for this, but then I got into something. And question 3, question 4 notes not done. I have to explain everything by writing down in here itself. Maximum number of groups with increasing length. Now, coming on to what the question says, I have indexed array, zero index integer array as usage limits of length n. Okay, I have some array, it has of length n. Cool. My task is to create groups using numbers from 0 to n minus 1, ensuring that each number I is used no more than usage limits I times. So basically the index says index of that number, index of that array is the number, and I can use that index at max usage limit of I times. I can use that index at max usage limit of I times in total across all the groups. So the problem says that I have to make some groups. In the groups, I will put some numbers. Let's say 1, 2, 3, 4, 5, like this. But the count of 2, the 2 is the index here. So at the index 2, whatsoever value of this usage limit is, I can at max put my 2 at that many times. Let's say I usage at the index 2, the usage limit value is, let's say, have a 3. So I can put my 2 3 times at max. But if it had a value as 1, so I can only put my 2 just once. I cannot put it twice. That's what the question is saying. Now, each group must consist of distinct numbers. So basically the indexes should be distinct in each group. I cannot say that, okay, it's 2. Let's say the count of frequency at I equal 2, the usage limit of 2 is, let's say, 3. So which means I can use the index 2, which means I can use the value 2 3 times. So I can't do something like this. Okay, in this group, I can put my 2 again and again. I can't do it. I have to put my 2 in some other group. So in one group, all the numbers coming in should be unique. Cool. It should be unique. Now, okay, that means that no duplicates and stuff. So for sure, each group except the first one must have a length strictly greater than the previous group. And for sure, the group length should be keep on increasing, which means if the length is 2, the next length should be 3. If the length is 1, next length should be 2. Next length should be 3. It should be keep on strictly greater, which means it should be keep on increasing. The group length should actually keep on increasing. Make sure that part. Now I have to return the maximum number of groups I can create by satisfying this condition. What was the condition like? Repeat it again. Conditions were all the groups should have unique numbers, which means every group should have unique numbers. The total number of numbers for any number, it should be less than equal to the usage limit of that particular number. And also groups should be keep on increasing, right? Okay. The groups should be keep on increasing. Cool. Now, keeping these 3 things in your mind, let's try to build the example by ourselves. How? Let's quickly see that. We will simply go and see, okay, one thing. I have a 1, 2, and 5. Which means 1, 2, and 5 are saying the frequency of number what? Of number 0, of number 1, of number 2. Of number 0, the frequency can be 1. So it is indirectly saying me out loud the frequency of every number. Cool. Now, I want to actually make as many groups as possible. Right? And I know the group length should be increasing. Right? So I know the group length first will be something short. Other length will be big, other length will be big. And I also know one thing, that if its length is big, which means, okay, if it is short, so what I will try to do is, I will try to take the group length of the first group as 1. The group length will be 1. The next group length, I will take it as 2. The next group length, I will take it as 3. It is the most optimal. You will see, na? because for sure the group, for sure I know it should be increasing. Group will start with some group length, so I will start from the group length as 1. It will be the minimum group length. I will just put in one element. Here I will just put in 2 elements. Here I will just put in 3 elements. Now again coming back, okay, I'm just trying to build my answer, right? And for sure, you know, there are 3 distinct elements. So for sure, remember, it is the frequency of every element, but it just shows me the elements actually are 0, 1 and 2. So I know I can have at max 3 distinct elements. So for sure the group length can be at max 3, right? Now coming back to how I will make it. Now for this, as length 1, I can either put a 0 or a 1 or a 2. What I should put in? Just let me know. I will simply try to put in some number that for sure it just don't affect my answer, and for sure, because see, I'm ultimately thinking of future. I'm a futuristic person, so I'm thinking of future, which means if I had to put in 3 numbers, because I have to put in 3 distinct numbers, I know I will put in all the numbers as 0, 1 and 2. If I put in all the unique numbers, so for sure its frequency will go as 0, its frequency will go as 1, its frequency will go as 4, right? Now to put in the 2 unique numbers, I will again try to put in 2 distinct numbers. I can't put in a 0 because it's gone. It had a frequency of 1 and 1 is already there. I'll try to put in a 1 and a 2, right? Again the frequency is 0, here the frequency is 3. Now again the 1 element I need to put in, so I'll put in a 2 here. Remembering, okay, its frequency will become a 2. So you know one thing, you got to know one thing. As I encountered, now I will just push it back, the same elements, I had a 1, 2 and 5. Now if you look back and see what my task, ultimately what I did was, I know I have these elements. The maximum frequency element I will just try to place in first. The maximum frequency element I'll just try to place in first, because it will just help me if I just place in this element. So for sure the smaller frequency number will actually help me make sure that, okay, when the length is more, I have to place in some unique numbers, so that lower frequency element will help me make sure in future if something happens to me or not. So one thing I got to know, okay, I'm concerned about the frequency of these element, and for sure something of that sort ki I should use the frequency of the maximum element first, and then the frequency of the lower element, and then the frequency of the lower element, and so on and so forth. So something is that, okay, I need the frequencies, because ultimately that usage limit is nothing but the frequencies. So I need the frequencies in some sorted order, so that I can encounter maximum frequency first, and then the lower frequency, and then the lower frequency, so as to make the groups more optimally. Or you can also think as the reverse way. To make the group as the bigger group, I will for sure need the frequency of the lower frequency for sure first, and then I can just keep on making the smaller frequencies. So anyway, I will need to sort my usage limit, which is the frequency. I will name it as frequency. It's okay. A frequency of 0 is 1, frequency of 1 is 2, frequency of 2 is 5. So I'll just name it as frequency. So for sure, I know one thing, that I'm concerned about the frequencies, and one thing for sure, that the frequencies should be sorted, because I want that everything which I encounter, which I use, should be unique and should have an appropriate count. Now, one thing we got to know so far, that okay, my frequencies should be sorted. Now coming back to the next question, next example, 1, 2, 2. Again, I know one thing, I will just simply sort these frequencies down. Now, as I sorted it down, again, maximum group I can form is 3 groups I can form. I can form just 3 groups. Now, if I form 3 groups, again, I will just try and push it in my brain. Okay, hey bro, can I make 3 groups? He will say you can for sure, but considering the fact, okay, let's say I make the 3 groups. I can make 3 groups. Okay, I just ask him, 3 groups I can make. It will just say 0, 1, 2. Yeah, you can make. Okay, cool. 0, 1, 2, I made it. Then everyone frequency will reduce. Okay, it's gone. Again, for 2 groups, I can make a 1 and 2. But what about this? Not remaining, right? Gone. So considering the fact, okay, and for sure, I am just greedy. I will just try to put the length as 1 and then 2 and then 3. So although the group you can make only 2, but here also, it was better if you just started from the length as 1 and then 2. So one thing for sure, I need, as I'm going from the starting itself, I know it is sorted 1, 2 and 2. As I'm going from the starting itself, I got the frequency as 1, frequency as 2, frequency as 3. So every time I know one thing, as I'm trying to build a group, I know, okay, it is gone. Yep. I know that, okay, every element encountered should be unique, which means if I am here, if I am at the group 2, I should have 2 unique elements for sure. I should have 2 unique elements for sure. If I am group 3, I should have 3 unique elements for sure. Okay. First thing came in my mind is, as I am at a specific group X, if I am at a group X, I should have X unique elements. And that unique elements, I can simply say, okay, if I am at group, let's say it is a group 2, because it's a group 0, group 1, group 2, right? If I am group 2, simply saying me, for sure I will have 3 unique elements, right? Or name it as a group 1, group 2, group 3, anything you can name it. Indexing are as 0, 1 and 2, but just saying, okay, every time it's a unique element because it's an index. Index is 0, 1 and 2. So at a group 3, I have 3 unique elements. So one thing is for sure, okay, at a group 3, I should have 3 unique elements. It is one condition. Other condition should be that for sure I should be able to place in the previous elements also, right? Because if I am placing some element as a group 3, but I should also make sure that I was able to make my group 1 and group 2 very easily. So my elements, which I'm just about to place an elements in group 3 right now, but I should also make sure in my mind, okay, I am trying to build my example. So my group 1 and group 2 should be made very good. So my elements, in total elements, it should be possible to actually, it should have been possible to place in the elements in group 1 and group 2. Only if it is possible, then I will just try to place in the elements in group 3. Now, it is one thing which we got in from this example of going on that, okay, I am making groups. I know I have just got the frequencies as sorted. I know as I'm trying to place in the elements in every group, I know one thing for sure, that I will be able to actually place in the elements. How? Let's see that. Now, coming back to if I am just building a group, next group and next group. Thinking in mind of what? I have these 1, 2 and 3 elements. It's just a group. Okay, the group 1, group 2 and group 3. Coming on to, if I just got this number 5 or this number 2 or this number 1, if I just simply sort it in the reverse order also, I will just simply place this number 2 here. It is gone. It will become a 4. Right? I'll just place it in the other number, which is a simple number as 2 and 1. Okay, it is again gone. It becomes a 3. Now I'll simply place in this numbers. What are numbers? Tell me what numbers. It's 2, 0, 0. Okay, I can simply place in the numbers as 0, 1 and 2. What if I asked you I had to make a group 3? Group 4, let's say. To make a group 4 itself, I should be able to place in 4 unique numbers. To get the 4 unique numbers, as I land on the 4th index, let's say it has, and for sure, if their indexes are itself 0, 1 and 2, I can make at max group 3. But imagining I had the 4th index also. Let's say its frequency is something. Name it something. Let's say it is 5. So for sure, I would have started by placing this, and for sure, you know, my frequencies are sorted. So I'm kind of placing my maximum frequency element at this location. Coming it back, right? It was a 1, 2, 5. Okay, it is a 1, 2, 5 and 5. Now I place another index, let's say another index 3, having the frequency as 5. Again, I will just simply go on and start from the end. I'll simply place a 3 here. Now I'll simply place a 3, 2 here. Now I'll simply place, okay, let's keep on reducing. It became a 4, right? It became a, and see, when it became a 4, see what happened. It will become a, as I placed it, it will become a 4. Sorry, it became a 4. It was a 5 at placing this, right? It will become a 3. It will become a 4 at placing my 3, 2. But please make sure that at every time it is sorted, because you are making sure that you are placing the most frequent element first, right? Although here it is not much matter because it is 4 3, next element is 2. So for sure, if I'm gonna take these 3 elements of the last, everything will come in picture. But please make sure if you're using those 2 elements, what I mean by that is, as you are using the last 2 elements to place in at this index 3 and 2, you remember it has become a 4 3, but I should make sure that everything is sorted 1 2 3 4. I will always take the most frequent element, most frequent last elements. Last for this group 3, I'll take the most frequent last 3 elements from this particular array. So what I mean is, what if it would have become a 1? Let's say if it would have become a 1, which is, let's say, very less number. Or let's say if I had said, okay, if everything is 4 4 4, let's say everything is 4 4, let's say everything is here 4 4. Just imagine it had been 4 4 5 and it had been let's say 4, or although it will not matter, but yeah, what I just mean to say is that please make sure that it is every time sorted. And that I will tell you that, okay, why I can't just simply sort this down every time. Cool. Now coming it back, I placed a 3, it became I placed a 3 here, I placed a 3 2 here, it became a 4, it became a 3. Initially is a frequency of 5. Again, I'm going to place last 3 elements, so I simply place in the last 3 elements, it will become a simple 3 2 and 1. Simply frequency reduced to 2, frequency reduced to 3, frequency reduced to 1. Right, I need to place the last 4 elements. I'll simply place them down, simply saying 3 2 1 and 0, simply reducing frequency 1, simply reducing frequency 2, simply like having the frequency as 0, frequency as 0. And for sure I can just place the last 5 elements. One thing got to know for sure, that at every time I'm choosing the maximum frequency element. For a group 1, I'll choose the maximum frequency element for the group 1. Let's quickly go back. 1, please see, I am just making it sure I give the time to this problem at every step, that you should actually make sure that it is working and that how it is working. So please stick to it. Like, you might think, okay, why I'm repeating the same stuff, but there's a high chance that many people won't get it. So please make sure that you understand everything, what I'm doing, how I'm writing it, how I'm building the intuition, right? Because code is very short and very simple, but how you reach it, it is actually important. Coming it back, now I have these frequencies. I choose the maximum frequency 1 element. I just place in here. When I reduce this frequency and my group 1 is made. Now for making my group 2, I will choose the maximum 2 frequency element. Here the frequency is reduced and I pushed it back in my something, any data structure. Let's say I choose a data structure, let's say TS, let's name it as D. I know it's a big data structure, but the D is not big, but yeah, no worries on that jokes. But yeah, we have this D as a data structure, which means I have all the frequencies in that data structure with me. I will just simply sort them out. So I'll just simply sort them out. I'll take the maximum frequency element. I'll take the maximum frequency element, right? Grabbing the maximum frequency element, and I'll just simply, and I know I just need to grab the maximum 1 frequency element. So in this data structure, I will just simply grab the maximum 1 frequency element, use it, and also make the frequency as reduce the frequency by 1 and push it back. Okay, now my group 1 is done. Again, I will just grab the maximum 2 frequency element out of this data structure, and again reduce the frequency of all of them and push it back. Cool. I'll just push in as 4 and 3. That is done. Again, I'll grab the maximum 3 frequency element from this data structure, grab all of them, reduce the frequency by 1 and push it back. Okay, 1 3 2. That's how you know at every time you are grabbing 1 2 3 and pushing it back. Now any data structure you can choose, either priority queue, anything, for every element, for every group. And for sure, you know, you can have at max n groups. For every group, you are grabbing out n elements. See, in worst case, it's the n elements. For the first group, it's just 1 element. For the next group, it's just again it is again 2 elements. For next group, it is again 3 elements. So for kind of xth group, you are grabbing out the x elements, and for sure grabbing out x elements and then reducing the frequency and pushing it back. So for n groups, you are grabbing out n elements and then pushing it back. by reducing the frequency by 1. That is what you are doing ultimately to solve this problem, right? So it is nothing but n for moving in the groups. For every group, pulling out n elements, and from a data structure, let's say it is as a priority queue. So for n elements, it will be n log n. So basically using a priority queue or something like that to get out the latest maximum frequencies element, it will be a n square log n algorithm, which would not work, because n is 1e5. Now, we will use the same stuff what we saw, but in just a different manner. How? One thing which I should be make sure at every point of time is that I should have some unique elements, because I need to make sure, okay, at every group, for the group number 2, I should have 2 unique elements. I know also one thing for sure, that I am moving in from right to left, right? I'm moving in from right to left. Right, I'm moving in from right to left, or you can also sort in ascending order or anything like that, and simply you are just moving in from left to right or anything like that, whatsoever you want. So I'm moving in from right to left. As I have encountered this first element, I know one group can be formed, right? For sure, because see, to make a group, what is the condition? You should have 2 unique elements, and also for sure the last group is made. Okay, and I'm going on from left to right, which means group 1 is made. If I am just looking for group 2, I'm looking, okay, group 2 can be made or not right now. Group 1 is already made, group 2 is made, then I'm looking for group 3. Then I know one thing for sure, that group 1 and group 2 are already made, right? Please make that sure that, okay, you know group 1 and group 2 are already made. Now you are just going in from the back. Now you encounter the first index. For sure, you know you have one unique element, but you also know if you're gonna make a one group, which means first group, it should have one element. So I'll just ask him, hey bro, do you have one element? He will say, hey bro, yeah, I have 5, which is more than equal to one element. So for sure, I can simply make one group. Okay, one group is made, and I'll simply go on to the next group. Okay, now I'm not gonna make the next group, and for sure, simply go on to next index, right? Because, okay, every time you're trying to go on to the next number, now I'll simply go on to the next index. I'll simply go and ask him, hey bro, can I make a group? For sure, you can make a group 2. Why group 2? Because you have 2 unique elements. You have iterated here to here. You have 2 unique elements. For sure, you can make a group 2. But to make a group 2, one thing you need to have for sure. I have just simply asked him, bro, I know you have 2 unique elements. I know you have 2 unique elements, because I am at the next index. I am at the index 2, which means from the last, I am at index 2. Or I am at index 1, which is nothing but the 2 elements I have. So I know you have 2 unique elements. One thing I am for sure is, okay, you will have 2 unique elements for sure. But will you satisfy the property that, okay, my last group count has already been done? Which means if I'm trying to make a group 2, I need to know one thing for sure. I should have in total 3 elements. For sure, I should have 3 elements. That I can easily say, okay, I have elements as 5 plus 5. I have 10 elements. For sure, I have at least 3 elements. Now, what if it would have been a 1 simple here and a 2 simple here? For sure, again, I have 3 in total as 3 elements. I am simply getting the count also from the last, and I'm saying, okay, I have 3 elements. For sure, everything can be made. Everything can be made, and you also can be made, because for sure, you can be made because you have 2 unique elements. And why that? Because I am at the index number 2 from the starting, which means I have 2 unique elements. So for sure, elements uniqueness is done. The count of elements in total should actually be there, because I need to consider, okay, I am not very, what if the count is, let's say, 1 here? As simple as that. If it is 1 here, if I'm going from the end, if it is 1 here, which means, oh, the total count is actually a 2. So if the total count is 2, which means after group 1 count is already done, I cannot make a group 2 again, because for 1 and 2 group to make all of them, I need a count of 3 elements should be there. 3 elements should be there for sure. So I'll just simply say, okay, the count of, as soon as I'm trying to make a group, next group, the count should actually be there. Nothing. So I just simply go and ask him, hey bro, the count is there. Yup. Yeah bro, the count is for sure more. Count, when I say count, it is nothing but, okay, the first group will have one element, next group will have two elements, next group will have three elements. So it's nothing but the sum of n natural numbers. So basically n natural numbers, n into n plus 1 by 2, right? So for the next count, which means here I am at the, let's say, the group 1. For group 2, the count is nothing but count of total elements will be, required elements will be group size, which means let's say the group size is 2. So 2 into, let's say, group size is g into g plus 1 by 2. That is the sum of n natural numbers, which I need to keep on and maintain by keeping track of the count of elements from the right to left. If that count of elements is actually in sync with, which means the count of these elements, it should be more than the count of my group size, because ultimately I'm concerned about the count and the uniqueness of these. Uniqueness I can just make sure by simply landing on the index, but count I have to make sure by simply grabbing the count of whatsoever I have had so far, because I know uniqueness was done earlier. Because ultimately if I'm a group 2, I need to concern about group 1, group, let's say if I am group 3, so I'm concerned about group 1 and group 2 uniqueness and count. Uniqueness of group 1 and group 2 was already make sure when I'm at group 3. Why? Because if I'm at group 3, for sure I will be at this index, which means 1, 2, 3 unique elements are already there. So uniqueness is already in touch, but the count needs to be make sure. And for sure I already know that, okay, group 1 and group 2 individually were actually possible. Group 3 I was about to make, and for group 3 making, I know that, okay, group 3 uniqueness is also done. I have the 3 unique elements. Group 3 count is actually good or not, simply getting the count of all these elements, and for sure the count of all these elements, the count of all these elements, which means for the group 1, group 2, group 3, which means the sum of n natural numbers, it is nothing but n into n plus 1 by 2. If it is less than or equal to my actual count, which I have of this particular array from end to beginning, if it is actually less than equal to this particular count, which let's say it is as a total number, a total sum, if this count is less than equal to my total, I am good. I can make another group. Cool. I just simply go on to another group to make another group. And when I say group, it is nothing but the count. Count is nothing but the group. Count is nothing but, okay, count. If the count is, let's say, one group is made. Count is 2, next group is made. Next, and so on and so forth. So I simply know by this I can simply go on at every index, and I simply keep on increasing my count. Count is nothing but the group itself. That's how you can simply solve it. So you saw there were many intuitions in between. And see, again I said question number 3 was actually a bit tricky to understand because it has many hidden things. Everything you have to prove. Okay, I am at a group 1. So let's say if I am at a group 2, if I am at a group 3, so I have to make sure that for sure group 1 and group 2 were actually correct, which means I have to keep on starting and making the group 1 and group 2 first, and then when I'm a group 3, for sure I have to consider, okay, my group 1 and group 2 are made correctly. For making that sure, for group 3 I need to have 3 unique elements. For that, okay, I am going at every index new, so for sure I will have 3 unique elements for sure. So now the only part concerned for me is the count, and I know one thing also, the count, the count was managed by group 1 and group 2 very good. I am at group 3, so I need to make sure that the addition of group 3 should also maintain the count. So I just simply go and check, okay, the count of everything so far I've get, because I know I can get the 3 unique elements. I know the left part is correct, but the total part should also be correct. So I just simply go and have this count, and I will ask, what is this count like? If it is actually in sync, which means this count of groups is less than the count which I can deliver, okay, because it is the input, it is the frequency which I can deliver. If this what I require, if the right part is what I require, the left part is what I have. If the requirement is less than what I have, then I can simply deliver that requirement. So simply you can deliver that requirement, and you can try for the next group, which is the 4th group. And that's how I can simply keep on going from next group to next group. So I'll quickly just modify the code. I have greater int. So it was just one thing I just did, and great. Okay, And yep, just let's quickly modify the code a bit, and that would be helpful. Boom, boom. Coming on to this, and it is done. Okay. Yep. Now, so that is what we have seen so far. Cool. Now coming on back to what if. Here we saw one thing. We are just grabbing the frequencies of what? Of maximum number. But I am here concerned about some frequency. We know one thing for sure. I was concerned about the uniqueness of the group 3 was done. The old group 1 and group 2 was already sorted. So I was again concerned about getting the group 3 as the answer. For group 3, I was just concerned about getting the total of what I have to deliver here. But you remember one thing, we're actually going on from big value. So what if I had a number of something having a very big value, which means the group size is small, I have a very big value, let's say 9. Cool. It is saying, okay, index is 0, 1 and 2. The group 1 is made. Group 1 is made. Cool. Having the index 2. If frequency reduced, again reduced. Group 2, again made. Group 2 is made. It is again frequency reduced and it is again reduced. Group 2 is made, right? Group 2 is made, having the frequency as 2 and 1. Now, to make the group 3, what you will see is the element which you had a very big value. But in between something got reduced to what? To 0. Also, although if you had reached here, you remember one thing for sure is that at every point of time you need to keep it sorted, right? So it should actually be internally sorted as 0, 1 and 7. But as I was moving in from the same issue which we encountered earlier, as we saw at every point, because why we are using a n square log n thing, because we know at every point if I reduce the frequency, it should actually become the sorted stuff, right? So it should actually be a sorted part. Now if it is actually sorted, then it will just land on to this particular index. If we just say, okay, I need to have 3 unique elements, but no bro, you don't have 3 unique elements. Even after you are at this index, you don't have 3 unique elements. So one thing is for sure, you don't have 3 unique elements. So to just maintain that sorted thing, if you are going in from right to left, will never get maintained. So rather what I can do is, I know one thing for sure, okay, the frequency is gonna reduce for sure, and I had this 0, 1 and 7, which means I know the sum will actually be more of what is required here. So although in imaginary mind it has landing at the index 0 saying I have 3 unique elements, and for sure the sum is also more, so it will just try to place in a 2, 1, 0, but this 1 is already vanished. So to just encounter that stuff, okay, I have to internally counter what if I get this thing as sorted, which means I have to get this thing as sorted. So I was concerned about bigger values should not impact my answer in my sum. So rather try to take the smaller values in the sum. What I mean by that is I had this numbers, right? I had this numbers as 1, 1 and 9, right? So you know that the bigger value will actually hamper your sum and will try to inflate that sum very bigger. But you don't want to inflate your sum. You want your sum to be as minimum as possible and that to be as authentic as possible. So you will try to go on from the starting itself. How? As you will just try to go and start from the starting. Hey bro, can I make 2 elements? Sorry, first, hey bro, can I make a 1 group? For sure bro, you can make a 1 group. Okay, cool bro, I just made a 1 group. Cool, I just used a 0. then he will just go and ask, hey bro, can you make two groups? Although I am at index 2, but the sum for me is actually a 2, but the sum required in total up till here is actually a 3. For sure I cannot make a group 2 right now. Cool. I'll just quickly go on to the next index. For sure the uniqueness is right now still maintained because I am at index 2. I have 3 unique elements, and for sure I can easily make a group 2. But now I will ask him, hey bro, my requirement is a 3. Can you give me 3? He will say, yeah, I can give you 3. My requirement is actually a 3 in total. I know you have 3 unique elements for sure, but my requirement is 3 in total. Can you give me a 3 as sum? He will say, yeah bro, I can give you 3 as sum because my sum is 9 plus 1 plus 1. It is actually a 11. So I can give you 3 as sum for sure. Cool. Bro, just give me 2 numbers. It will just give me 2 numbers. Here is actually a tricky part. It will just give me 2 numbers. It can give me 2 numbers. It will just give me this and let's say this. For sure it has 2 unique numbers. It will just give me 2 unique numbers. It can just simply give me 2 or let's say 1. But here you saw it is giving you 2 and 1. But in actual it will not give you something like this. It will give you, if you had a 1, 2 and 3. Just saying, if the frequency is nothing but a 1, 2 and 3. Elements are 0, 1 and 2. For the actual index for the group 1. See, understanding the concept, firstly, this was one case. Firstly, we saw n log n thing. Then we saw, okay, it will work for sure. Then we saw, okay, it will always work. But having the end as sum, it will actually, my larger value will inflate the actual sum I have. My larger value will inflate the actual sum I have, and the required sum will actually become for sure less. So what we thought is internally, we'll go on from left to right. But there's a slight catch here. Logically, going on from left to right will not indicate the actual value being placed in, which means here I know I have to get first group. He will just go and ask him, hey bro, can you give me 1 group? Yeah bro, I can give you 1 group. Right now I have 1 value. Okay, I have 1 unique value. I'm at index 0. I can have 1 unique value. For sure I can give you 1 value. Thus I will simply give you index 0. I wrote the index 0 here, but as a group it will not come in. I'll show you how. As I go on to next group, I'll ask him, hey bro, see above is index, like the below part is frequency. Cool, which is nothing but the usage limit. Now again I will ask him, for sure he can give me 2 unique values because he's at index 2, and for sure the sum of this particular stuff is as minimum as possible because I have sorted it in ascending order. So that is as minimum as possible, right? If it is as minimum as possible, I'll simply go and ask him, bro, I in total require 3 elements. I in total require 3 elements. Can you give me 3 elements? Yeah bro, I can give you. My sum is also 3. I can give you 3. And for sure, I can give you 2 because ultimately I am concerned about the 2 unique elements. I am at index 1. I will have 2 unique elements. So I can give you the elements unique as 2. For sure, I can place in here. What? I can place in here. That is the again catch. You will place in index 1 and index 0. Although you will see you place index 0, but ultimately as you are going on, this will actually become a 1. Logically thinking, at this point it was just saying, because see, at every point I'm just trying to say, is it possible to make a group 1? Is it possible to make a group 2? Is it possible to make a group 3? To say if it is possible to make a group 2, I have 2 conditions. That my previous group should be made very easily, okay, and I was at this point, so I know, okay, my previous group was made very easily. As I at this point, I am trying to make a group 2. I am asking, can I make this group 2? For that I need the uniqueness, okay, I can have the uniqueness for sure. I also need the count. Then to have the count, I should make sure I know I have 2 unique elements which will be placed here. The remaining elements will actually come in, and for sure all these elements are as minimum as possible. That is the minimum requirement I can provide, and that is the maximum requirement which he needs. His requirement, maximum requirement, I am fulfilling with my minimum requirement, which means for sure I can fulfill his requirement. So ultimately, logically thinking, when you are going on here also, you just place in the index 1 at this place, but as you will go on to group 3, you will see that it will get replaced with the next 2, because again as we go on to group 3, I know my group 2 is made. my group 3 as I land on 2, as I land on 2, I can know I can have 3 unique elements. Now for these 3 unique elements, I will just go and ask him, hey bro, what is the minimum what you can deliver? Hey bro, I can deliver the sum as 3 plus 2 plus 1, which is the 6. Hey bro, what is the sum you require for actually having a group 3 as well? Hey bro, for group 3, for having a group 3 as well, I need a 3 into 3 plus 1 is 4 upon 2, which actually is 6. I need a sum of 6. So for sure, my 6 is actually more than equal to my this 6, which means which I can deliver is actually more than, and that is C. It is a minimum which I can deliver. I can for sure any day of time can deliver this. It is a minimum I can deliver, and the maximum what he requires a maximum of 6. I can deliver the minimum of 6 for sure. So simply I can say I can place in 3 elements, but logically what the elements will be placed right here will actually be a 3 2 1 going, sorry, 3 2, sorry, a 2 1 0. Going backwards, you will see it will become a 2 1, it will become a 2. That is how logically, firstly, that's the reason I just firstly explained you that how logically I am placing the maximum element, but then we saw that of placing that maximum element, there's a bit catch, because you are delivering the maximum what you have, but you should deliver the minimum of what you have, so that the maximum he can ask you from. He will ask the maximum what he wants, but you should deliver your minimum as minimum as possible, because you want at mid time, because because as you saw at mid time it can happen as you're going from right to left. It can happen that okay, it will become a 0 in between. As we saw, it became a 0 in between. That's the reason I'm going on from left right, that if anything becomes a 0, it should become in the left and not in the right. That is how you can simply solve this problem. I know this is a very, see, that's the reason I just showed you. To actually solve it, it's very easy. Many people will just straightforwardly say, okay, it is happening like this. But there are many steps to this problem which actually make it the actual tricky problem. Fourth one is very easy, very straightforward, very easy. Much easier than this. But to actually prove it, people have just said, just simply sort it down, have the frequency. But I showed you that at every point, why something matters, why the maximum frequency mattered. Okay, maximum frequency mattered. But then we realize, okay, having that maximum frequency will actually not imply the thing which we know, that we have to also sort the frequency element which we had taken. For that, I will take the minimum, I will start from the minimum frequency elements, and then we'll try to apply the same stuff which I was doing it earlier. And that's how you can simply solve this problem. If the folks have, yeah, see, there are simply four steps to this problem. And that is how you can simply solve it. You saw it here. From starting beginning, one step, first intuition was that you have to sort this down. Next intuition was, at every group, I need to have the maximum K frequency groups, maximum K frequency elements to actually make that to make the group X of size X, I need to have the frequency 3. I need to have 3 unique elements having the maximum frequency. So one thing is for sure, if I just simply sort this down, I will take the last 3 frequency elements. If I take the last 3 frequency elements, for sure I can simply reduce the frequency by 1 and can simply place that 3 elements in my group. Now after placing the 3 elements in my group, I know I have to again sort this stuff down, so as to make sure that I will not have to sort it again and again. I have simply got to know one thing. Okay, what I'm concerned about is the uniqueness of the elements and also the count of elements. Uniqueness, as I'm at the index, I will for sure have the valid uniqueness, but to get the actual count, I will have to apply something that, okay, for the count to be there, I have to take the total count of what I can deliver versus the count what he needs, which is the count of groups, and the count which I can deliver is the count of frequencies. So the sum of frequency at that index, so I know the sum of frequency at that index it should be more than the count of groups, which means the sum of the elements in the group total up till that point, it should be less. Now, okay, it is one thing. Now what we are thinking was okay, I will go on from right to left, but yeah, going on from right to left, which means I'm grabbing the maximum elements in my frequency. But ultimately, we also remember that I was sorting the things down. So the elements of the maximum frequency should not come. I should actually give in the minimum what I have versus the maximum what he can provide. So that actually, even if after doing a sorting, he will still take the minimum ones and not the maximum one. And that's how we can simply solve it. Right? See, even if you have not understood it, I highly recommend to actually go back again and actually point everything down, because okay, it's one point, it's next point, it's next point, it's next point, because it's actually incremental. Because the code which you will do and the dry run which you will do, it's actually different, very different, because you saw the code which I was writing and the dry run which I was doing was very different. You saw in the beginning here the element was a 0, then it changed to 1, then it changed to 2. It is changing at runtime, but logically saying it will not change. By dry run, it is, I'm showing you it is being changed, but logically it will not change. And why it will not change? That is when we saw, if I go on from right to left, that's how we saw, okay, it will logically not change. And the issue which we encountered while going from right to left was the issue of counting maximum, right? To encounter that thing, we actually start going from left to right and did the same stuff. That is all. See, question 3 again, I am saying, although people will just straightforward say, many people will just do a rectification question number 3 and will just simply have it done. But I will highly recommend, being in our group, being in our channel, you should actually go on to the proper intuition of how it is being done. Many people have just explained it very roughly, but I will not do that. That's the reason I just specifically explained everything down. Cool. Let's quickly jump onto the code. But yeah, before that, if we can smash that like baby to 95 likes, that would be super great. Just 4 more likes. Now, as I showed you, I will just simply sort in ascending order. Then I have the total, which is what I can deliver. It is what I can deliver. What I can deliver. It is the count. Count is nothing but, it is nothing but saying, okay, my count is nothing but the group count. Initially, the groups are actually 0. It is nothing but the group count. Group are actually 0, right? Now, as I go on to any index, right? I am going on to every indexes, right? I will simply, what I can deliver, I will simply add that. Simply add that, just saying, okay, it is the total which I can deliver so far. Now, he will go and say, the count is initially 0, which means the groups are initially 0. I will try to make the new group, which means the groups are actually, let's say the initial group is actually count groups. Initial groups are actually count groups, which is actually count groups, which is actually groups as 0. Right? Next time, I know I'm gonna increase a group. So if I increase a group, I know the count will become count plus 1. Right? The group was actually earlier count. So next time the group, if it is actually increasing, so it will become a count plus 1. So if the group which is actually going to become a count plus 1, which means I know now the group will actually be, let's say 1 or 2. So the new count of group will be count plus 1. New count of group is count plus 1. I know to have the sum, of the numbers, if let's say I see the group is 2. Groups are 2. So the number of numbers in total will have been here as group into group plus 1 by 2. Which means if I have the group as, let's say 3, which means here will have 1 element, here I have 2 elements, here I will have 3 elements. So if the group is 3, the count of total numbers in this group range will be group into group plus 1 by 2. Just a sum of 3 consecutive numbers. It is nothing but 3 into 4 by 2, which actually is 6, which says 3 plus 2 5 plus 1 6. In total, I have 6 elements which I will have come in. So if the group count is count plus 1, because ultimately as I am having another group, so my count of group will increase by 1. So the count of all the elements in this count plus 1 number of groups is nothing but count plus 1 into count plus 1 plus 1, because it is n into n plus 1 upon 2. It is nothing but count plus 1 into count plus 2 upon 2. That's what I have written here. Count plus 1 by 2. Because I'm trying to make the group count from count to count plus 1. I'm trying to make it. If it is possible, if it is possible to make the count +1, so I'll simply make the count +1. And how to check if it's possible? The minimum what I can deliver and the maximum what he needs. If it is more, what I can deliver, if it is more than what he needs, I can for sure increase my group count. I can increase my group count. So my count of group is actually increased, and I'll keep on doing it until it is possible, and I will simply return the maximum group count which I can have in the last, which is this particular count. And that's how I can simply solve the problem. Cool. I hope that you guys got it. It was a very lengthy problem. Like, that's the reason I said it was 4 questions is much easier than this. Much easier than this. I don't understand the fact that how come, because see, the code is short. The code is very short. You will see, very short and very basic. The code is very short and very basic. But to explain that why it is happening, why the fuck it is happening, because every time you will see everything what you say in the code and what you will dry run is both different, entirely different. So how to prove that what your code is doing is actually correct is by the proper intuition which we showed, which is the 4 steps, right? And that's how I can simply solve the problem. Cool. Let's quickly jump on to question number 4. See, I know the questions are hard AF, both question number 3 and question number 4, but yeah, still, we are here to make hard questions easy. See, if you think question 3 was hard, please go and watch it again, because it was actually hard, right? Now, coming on back to question number 4, but can we please smash that like to 100 likes? But firstly, let's quickly jump on to the comments very quick, and then we'll quickly jump on to actually the question number 4. It's easy. But yeah, before that, can we please smash that like baby to 100 likes? Just 2 more likes, that would be super great. Going on back, हाँ भाई एक मिनट भैया, प्लीज सॉल्व थर्ड यूजिंग बाइनरी सर्च. भाई थर्ड इससे इतना लंबा हो गया, बाइनरी सर्च से तो और लंबा हो जाएगा. वी विल हैव इट मे बी इन एक्स्ट्रा बट नॉट राइट नाउ. लेट्स क्विकली जंप टू कमेंट्स. Sashwat Shukla, oh right, monostack, that is done. How many questions did you guys solve? DK, that is done. How you came to that intuition, that is done. थर्ड वाले का इंट्यूशन आ गया था, बाइनरी सर्च का इंप्लीमेंट नहीं, दैट इज डन. भैया प्लीज सॉल्व थर्ड यूजिंग बाइनरी सर्च, दैट वी कांट बिकॉज़ द थर्ड इज ऑलरेडी हैड गॉन बिट लॉन्ग. अरे पुतिन भाई, आप कहाँ लीड कोड के चक्कर में आ गए? एकांश, हाँ भाई, करना पड़ता है, प्लेसमेंट्स हैं तो वो तो चलता रहेगा. इफ यू सॉर्ट देन विच इंडेक्स रिलेटेड टू विच फ्रीक्वेंसी, दैट फ्रीक्वेंसी. See, it is just saying we have different elements. Indexing and frequencies are nowhere related, because for sure I'm just concerned about the uniqueness of the elements, right? It does not matter since we only had, that is correct. Aryan, can you make 4 subjects 1 short video for interviews? My code is not that great. Got the intuition, thanks. Can you take the example frequency is 1 2 to 5? Yep, that. Yeah, fuck you, you back said in my fart again. I'm concerned that if the last index have frequency very high. Yeah, that is correct. Yeah, Ritik, that we showed in that's the reason we optimized it, taking from the start itself. Can you show coding screen? Today's contest was tough, that is correct. Was able to solve only 2. I think it will be able to more productive. You can speak it bit loud, bit slower. His frequency is good. Okay, you can reduce playback speed. Confusing, slow. Yeah, solve 3 using binary search. Best example for why we start from the minimum frequency is 006. That's correct. Array hard questions required for placements. A medium to hard, I would for sure say. These hard questions as in interviews was able to solve only 2. Not in interviews for sure, but if he asks it and if you even solve it in mid, or even if you solve it until, let's say, a specific, because see, I showed you every step was progressively increasing to our answer. We started from a very naive approach of sorting it out. It was the first intuition. Then we reached a solution of n square log n, when we realized that okay, we will just have it done, but we realized that okay, it won't work. Then we actually went it from back to start, and we realized okay, back to start we have an optimization of O of n log n, but still that would actually give a wrong answer if we do something like this, but it will actually work. Then we moved in from start to end. Oh, That will actually work. So it has a 4 stages of intuition. If you moved on to any stage, that will actually add up your score in interview. That can be asked for sure in an interview, but it is never the concept of, or never the fact that how much you solve it. It is always that, okay, sorry, it is never the concept that, okay, if you solve it completely or not. It is always the concept that, okay, how much you were able to go close to a problem, how much you were able to build in and debug, okay, build in and do a progressive thing, okay. I was able to bring in something, That's the reason I just went in from although I could have started to say in the beginning itself, like I have seen many YouTubers do, just show the code and then they will just let you know the intuition. But I specifically showed you it is done. Okay, it's giving a TLE. Now it is giving a wrong answer. Now it is actually giving a right answer. Because every step mattered to reach the final solution. Simply just speaking out, okay, I can simply sort it down. I will have the frequency. You will never understand how that worked. That's the reason we actually move in from very start to every intuition. First, second, third, and fourth. Cool. Let's quickly jump on to question number 4th. It's actually not that hard. Just the coding part is a bit thoda messy up, but the rest part is just very straightforward. See, count pass. But yeah, before that, can we smash that like baby to 105 likes? Just 2 more likes, that would be super great. Counts path that can form a palindrome in a tree. First thing, you know palindrome, you have to count paths, it's a tree. Now, coming in back to what we have to do. We are having a tree. Okay, what's a tree? It's a connected undirected graph that has no cycles. Cool. One thing it has no cycle. It's a connected graph which is undirected. Now, for sure, we have a tree rooted at node 0, which means I know the root will always be node 0, which means I can always start my tree from node 0. I know the root as fixed. That is a very big point. Although in this problem, you will just say, okay, Aryan, I could have simply started from the 0 itself. But yeah, simply saying the root is fixed will help you a lot in life. Because you can always start from root. Root as fixed will help you a lot. Root is fixed, it's a node 0. I can simply say I can start from the node 0 itself. Now, consisting of n nodes numbered from 0 to n minus 1. Okay, I have a tree with n nodes numbered from 0 to n minus 1. The tree is represented as a 0 index integer array parent of size n. Okay, it just says I have this particular parent array. It just say, okay, indexing is 0, 1, 2, 3, 4, 5. Parent of 1 is a 0. Parent of 1 is a 0, right? Parent of 2 is a 0. Parent of 2 is a 0, right? Parent of 3 is 1. Parent of 3 is 1. Parent of 4 is 1. Parent of 4 is 1. Parent of 5 is 2. Parent of 5 is 2. That's how you can simply build the tree out. Parent of 0 is minus 1, which means 0 has no parent. 0 has no parent. Now, same I have given the actual their edge character, which means for the first one you can simply ignore because it is for the 0. For 1, for the same, for this particular pair, which means having 1 as a parent as 0, the actual edge has the character as C. Okay, I have the C as the character. Here I have the A as the character, which means from 2 to 0, I have A the character. Here I have, again, from 3 to 1, I have the A as character. I have A as character. From 4 to 1, I have B as character. B as character. Right? Here from 5 to 2, I have C as character. I have C as character. Now, one thing, from the input, how you can just build this particular tree out. Right? That is done. I have not went to the question itself, but yeah, your question is done. Now, what I have to find out is, I have to return the number of pairs of nodes u comma v such that u is less than v. One thing again for sure, the pairs which I will count here, it should be such that u is less than v, which means if I do a double counting, what we usually do in double counting is we count the pairs as uv and we also count the pairs as vu. So if you do something as double counting, please make sure you divide your answer in total last by 2, because you know you did a double counting for sure, because you only want the single count where use less than v. So here only one count will be required. So if you are doing a double counting, which means if you're taking a u and v, both the pairs as equal preferences, so for sure please divide the answer by 2 in the last. I don't know what the answer is, but yeah, make sure to do it, because you know that u is less than v. I'm just grabbing all things out from the problem itself. Now going it back, and the characters assigned to the edges of the path u and v from palindrome. So what I'm saying is, if I choose any u, any v, right, I will choose a path between them, right, and you know for sure that the shortest path will be unique. Mark my words, I'm using the word shortest path. Why not the path? Because between 3 and 4, the shortest path is AB, but one of the paths, it can also be ACCB, right? It can also, and when I say path, I consider the root as my prime thing. So I can also say, okay, as AB is the shortest path, and it will also always be unique because it has no cycles. But you can also consider the path as ACCB. That's also one path. ACACB, it's also one path. But yeah, I'm concerned about the root. So I will consider everything from root to bottom. I will not go beyond root. I will not go beyond root. Although here you will see, if I ask for the path from 1 to 5, then the path will actually be simply a CAC. But when I will say a path, see, whenever it's actually something out of this problem, but if you are asked of a path, you are having a root. If I ask you for a path between two nodes, then please make sure that how you deliver the path is going to a root. Okay, the path is 1 here, going to a root. The path is 1 here, right? That's how you should simply, if you had done the LCA kind of concept, so it is what they teach in LCA, that if you want to find the LCA, lowest common ancestor, simply go on to the root and ask the root itself. If you not, just simply remember this fact that if I ask you path between two nodes, simply go and tell the root, okay bro, path from 1 to root is C, path from 5 to root is a AC. So basically a path from 1 to 5 is actually a CAC, which is actually a palindrome. Why a palindrome? Because you know that only the one element is occurring, once. Because a palindrome is something, and see, you can rearrange this palindrome, which means even if it is a CCA, I can rearrange that and make it as a CAC, right? So if I have any combination of characters, then it can be a palindrome if the frequency, if the count of unique element, which means the element which has a frequency as 1, the element which has a frequency as odd, I should say, it should occur at most once. That will be a palindrome. But Aryan, like you suggested one thing, that I should go to root to get, okay, what is the path like? But what if I am just asking you out the 3 to 4 path? So the path between 3 to 4 is actually a AB, but you are asking me to go to the root and will again go and come back. So it will be a 3, which it will be a ACCB. Although when you do LCA kind of problems, then you actually make sure that whatsoever LCA you have, which means the LCA for 3 to 4 is actually a 1. So you will just make sure that you subtract this value from actual answer. So you will just go and ask him what is the LCA, what is the count from 1 to 0. It is actually a C. And for sure, if I am going above, so it will also come down, because it is above, also come down. So it will be counted twice for sure. Anything above my LCA. LCA is lowest common ancestor. That is not useful. It's just a term which you need to remember. Okay, it is not useful at all here, but it's just a term I am relating to, that okay, if I have a lowest common ancestor, I will go and come back from that ancestor again and again, so that ancestor count will be actually counted twice. So usually in the problems of LCA, what we do is we just get, okay, what is the path or what is the frequency like, and then I can simply reduce that frequency twice. So I can simply reduce that frequency twice to get this particular string. But in this problem, I'm concerned about what? I'm concerned about the palindrome. So even if I go and have the frequency as ACCB, you will see that, okay, the extra character which are coming in have the frequency as even. Anything which is added in a palindrome as even times will not impact the palindrome. So for sure, I can actually not have to make sure, okay, what is the LCA like or anything like that. I know, okay, I don't have to go into what is LCA, how the LCA is made. Even if I am going to root and coming back, I just would know one thing: element which are extra added, the character which are extra added will be added twice, and those added twice elements will not impact my palindrome, because I know for sure the frequencies of character which are actually even, they never impact my palindrome. Only the odd frequencies element impact my palindrome. So one thing it is one thing we saw out while reading the problem itself, that okay, it is a tree rooted. I have to go on to all the pairs of nodes. When the pair of nodes comes in picture, that okay, we have a slight kind of idea that we usually go on the root itself, because we know our root is fixed. So whenever the pair comes in picture, so to actually easily analyze the pairs, so what I do is I just break the problem from one u to v. I just break it to u to root and v to root, and that's how I can simply solve it. So when this UV pair the pair can think it came in picture, so I know one thing: I will break it down at the root itself. Now, when I was breaking it down at the root itself, then I realized, okay, what if I have both of them at this side? Then for sure I would be knowing LCA, but Aryan ने LCA तो पढ़ाया नहीं है, so is the LCA required? Maybe not. So let's see. Then I realize, okay, for this thing, I would be required as AB. But then if I just go on the root itself, which means from U to root and then from V to root, so basically it will be a AC and a BC or a CB, anything you can write. For sure, anything which is counted above LCA, it is the lowest common ancestor. If it is counted above LCA, for sure it will be counted twice. So if it is even counted twice, so that will not affect my answer, and I can simply go on to it. So one thing I got to know for sure, that I will utilize this root to actually break my problem to from root to every part, which means from root I will go on to every node. From root I'll go on to every node. From root I will go on to every node. From root I will go on to every node. From root I will go on to. By this you will get to know that, okay, your task of going on from every node to every other node got reduced to just simply going on from root to every other node. That is how we actually solve these kind of pair problems in our tree, by simply saying, rather in going to every pair u comma v, because you know if the nodes u are actually, if you go and look at the constraints, u is actually 1e5. If the u is 1e5, if the v is 1e5, which means I have 1e5 nodes, so u comma v pair, it can be 1e5 into 1e5. That's actually very lot. So that's the best task, that okay, from root go on to every 1e5 pairs. That will only take your 1e5 time. So now I have just got a rough idea, okay, of what maybe I can do, which kind of maybe help me. Now coming back to what I have seen so far, is from root I can go on to any node 1, 3, 4, 2 and 5 to get the answer. And what I mean by answer is, I'll just quickly go back. See, you remember, I need to go on to pairs. To go on the pairs, I will know I have to keep track of from root to that node. So I know from root to 1, it will be a C as a string. From root to A, I will have the CA as a string, right? From root to B, from root to 4, I will have a CB as a string, right? From root to this particular thing, I will have A as a string. From root to this node 5, I will have AC as a string. By this, right now, I know, okay, up till this point, it is the string. It is a string. It is a string. It is a string. Cool. Up to so point, I will know, okay, it is what I can make from this particular tree right here. But now you remember, I'm concerned about what? I'm concerned about the frequencies of these characters, because I know if I want to make a palindrome, let's say if I choose this node as CA, now to make this a CA as a palindrome. CA as a palindrome. I know one thing. Firstly, anything which comes in should actually be saying, okay, A should come in, or a C should come in, or any characters coming in even number of times. So one thing I was concerned about is, okay, I'm concerned about the characters. Okay, I'm concerned about the characters. I'm concerned about the frequency of these characters. Okay, and specifically I'm concerned about the odd frequencies of these characters, because if the frequency is odd, it will actually impact my answer. Even frequency will not impact. If I had, let's say, A, C, so for sure this A, C, I can also write the same thing as simple A, C. I can simply write the same thing as simply AC, right? Or if it is A, C, I can simply write the same thing as simple C. That's it. So I know, okay, I just only concerned about the odd frequencies. Cool. Now I am concerned with the character, the frequency, the odd frequency. I know the characters are 26, so I need to maintain these 26 characters. I need to maintain the frequency of these 26 characters at every point of time. But in frequency, I'm only concerned about the odd frequencies. So rather make sure that you concern about the odd frequencies of the character. Now, to maintain this character, I have to maintain the character, which means I will make the entire list of characters or something like that. I can make the entire thing. Let's say it is an entire string or something like this. But maybe I can use something very easy to write. I can also write this as the same stuff, okay, entire characters. But then I will also have to maintain the frequency as odd or not, maybe by using a map or something. Can I just club this down, same stuff, by doing one thing? I need the character, I need the frequency of character, I need the odd frequency of the character. So can I club this down as using one stuff for every node? Yeah, I can. That is how a bit masking comes in picture, or bit manipulation comes in picture. But yeah, before that, if folks are watching in, can we please smash that like baby to 115 likes, just 115, just 2 more likes. That would be super great. So I was concerned about the character, I was concerned about the odd frequencies, right? Because one thing is for sure, I'll just show you. One thing is for sure, if I have a AC, I was concerned about getting a A also, so that the frequency will become even. Odd frequency will become an even frequency, and for sure it will just cancel out. The only will remain is a C. Then maybe I can just handle it out. So for sure I was concerned about the characters and the frequency and the odd frequency. So what I thought is, I can use bit manipulation, which means I have 26 characters. I can represent every bit as a character. Sorry, every character as a bit, which means I have these 26 characters. So for A, I will use first bit. For B, I'll use next bit. For C, I'll use next bit. For D, I'll use next bit. For E, for F, and so on and so forth. So I will have a bit size, which means I will have 26 bits with me. 26 bits with me. 26 bits with me. Every bit representing every character. First bit will say the representation of A. If it is 1, I have a A. If it is 0, I don't have a A. But Aryan, having a A, not having a A. But you wanted na ki how many A's are here? No, I just wanted, okay, if A is occurring odd number of times or not. Which means, let's quickly boil it down. So I have the string as A. I have the one character as A. Now I will represent that character as a 001, right? If I have a B, I will represent it as a 010. If I have a C, I will represent it as a 100. You got to know one thing, okay? For every character, I will just make that bit as set if that is actually present. But okay, if it is A. Now let's say next time again you encountered a A. So for sure, you know one thing. Here the count by this, if I just view this number, I will just know one thing for sure in the beginning. I have one A with me. If I encounter another A, then am I concerned of this A? Now, no. Why no? Because I know one thing for sure. Why? What? That if the count of A is even, I'm not concerned about it. So it should have become a 0. anything, if I had to make it as a 0, what I can do, if I had to make a 1 as a 0, what I can do, I can apply a AND operation or a XOR operation, right? Or a XOR operation, right? Now to make this A again as a 0, because you know one thing, again a came in picture, I have to make it as a 0 because ultimately the A count is actually a 2 here. But what if I say again a came in picture? Again, if a came in picture, so for sure you have to make it as a 1. Now to make a 0 as a 1, what you can apply is either a OR operation or a XOR operation, right? So one thing, to convert this A to 0 to 1 to 1, because as the frequency becomes even, I know I want to convert that to a 0. If the frequency becomes odd, I want to convert that to a 1 back. So we know I can either have a AND XOR, I can have a OR XOR for sure. The thing which will work both times is actually a XOR. So one thing I got to know, I can simply apply a XOR operations every time I will encounter a character to actually convert that character, and will know if that character is 1. How to convert that character? By simply using a XOR operation. I'll simply use a XOR operation to actually convert that character. And if that character is 1, it will just represent me. It has an odd frequency. If that character is 0, it will represent me. It has an even frequency. And even frequency are not considered out because ultimately even frequency will cancel out my palindrome. Cool. Now we will jump. Now by this, what we will get to know it at any point of time is if I have any element, if I have, let's say, a string, let's say A, B, C, A. So it will have the representation in the binary form as what? A will be 0, B will be 1, C will be 1, saying me I have a B and C as the odd frequency and A as the even frequency, which means even if A is present or not, it does not matter to me, because for sure I know one thing, that A has a frequency as even, and I am using a palindrome for which frequency needed is actually a even frequency. So for sure it is how I can represent my number. Now coming in back to what I can do. My characters is done. I will represent this in the form of a number by using my 26 bits, and for sure we know that the integer is a 32-bit integer. So for sure I can represent every list of these characters in actually an integer variable, because for sure it's a 26 bits which is less than equal to 32 bits. So I can represent this in the form of the bits. I'll use the bits, convert that to a number, and by this number, if the frequency, and to maintain the frequency is odd, so for sure that thing would be a 1. Now coming in back to how I will represent that. Again, going it back on the root, I just say the frequency of everything is a 0 here. Again it will, and see how it will just simply go on. I know I have the C, I have a AC, I have a CB, I have this. Simply, if you have to go on, simply you can use a simple DFS or a BFS traversal to actually go on from root to bottom. That you can simply do. Now I have to convert this character to actually a integer number, because I am maintaining my integer as the identity of this particular thing. Now to have this C, I will simply use a 100. Remember, I am representing in the form of a binary form, but the number is actually a 4, right? Cool. Now to have this AC, you know what? You know one thing. You have this AC. Now you are going in from here. From 0, 0, 0, you encountered a C. You did a XOR operation on this 0, 0, 0. 0, 0, 0, XOR with C. When I say C, I am saying a 1, 0, 0. You remembered what? You remembered why? Because a C is as a 1, 0, 0. I did a XOR with this 1, 0, 0 to actually get what? To get what? To get a 1, 0, 0. I did a XOR. You remembered why a XOR? Because you know that the XOR will be the operation which you will do to actually encounter or basically have multiple elements coming in picture. Cool. I'll simply encounter a XOR. I'll simply get a 1, 0, 0. Now again, I have a 1, 0, 0. I'll go back down from this 1, 0, 0, which is this. I encountered a which is actually a 0, 0, 1. I'll do a simple XOR. I'll get a 1, 0, 1. Okay, cool. This can be represented as a 1, 0, 1. I'll not rub it. It is as a 1, 0, 1. Cool. I simply, it's a simple DFS. I'm just providing my upper mask. It is the upper mask. I'm giving the upper mask to my child, and this is being encountered meanwhile. Now to get the value of this particular value, I simply know, okay, my above is 100, which is actually a C. I encountered a B, so simply do a XOR with actually a B to encounter a new element, which is CB. It is showing me I'm getting a CB. Okay, I get a CB. Again, from root, I'll go on to this particular A. I'll simply get what? I'll simply get a, from 0, 0, 0, you encountered a A, which means a 0, 0, 1 you encountered. Simply doing a XOR, you got a 0, 0, 1. For sure, I got a 0, 0, 1. Okay, I got the 0, 0, 1. Now, again, if I just go back, I have the 0, 0, 1 with me, 0, 0, 1 with me. I encountered a C. Okay, I encountered a C, which means a 1, 0, 0. I simply do a XOR. I simply get a 1, 0, 1. Cool. I'll simply get a 1, 0, 1. So it is as a 1, 0, 1. Aryan, what if I had a node, let's say root, and then I have a root and then a node, let's say 1, and then a node as a 2, and then a node as a 3, and the node as a 4. It is having a, let's say, A, it is having a B, it is having a A, it is having a C. So what it will do, actually in general, it would have done as A, it would have been AB, it would have been a ABA, and it would have been a ABAC. Your hash or your mask will actually represent it as a 0, 0, 1, right? It will actually say a 0, 1, 1, right? It will again say a 0, 1, 0. Why? Because the count of frequency of A has become even. That's the reason it has gone back to 0. It will again say a 1, 1, 0. That's how it is showing your count of frequency of A is even. That is no more affecting us at all. Cool. That is how your mask will actually build in for this particular tree. Okay. Now you have built in your tree. Now you have built in a mask. Now your task comes back to what? Comes back to actually the stuff of what you had to find. What you had to find was, let me quickly erase this dirty part, which I have made it dirty. Cool. Why I erased everything now? Cool. Let's keep it like this also. Like this only. I'll just erase this particular part. Yeah. Now, I have just made this down. I know I have made this down. Again, going back to what I had to find. I had to find the pairs which actually make the palindrome. Now, coming back to the palindrome concept. For sure, I know I will go on to root. Rather than going on from the nodes, I'll go on to root. Now, to just ask him, hey bro, for me 101. Hey bro, for me 101. Which is actually saying, okay, I am C. Up till root, I am C. Who all can make a palindrome with me? That's a simple question. Which means, if I just say one thing for you, in general, I have a node. Let's say it is a root node. And then for this, it is a node here. And then a node, let's say here. I know it's a, I know it's a C, I know it's a C, right? At this point of time, I just ask him. It is actually saying, okay, I am A up till here and AC up till here, and that's actually a C. If I just say up till root, it is actually a AC. Up till root, it is actually a C, right? If I just go and ask again, the hash of him, or basically a mask of him, it is actually a 001. It's actually a 101. It's actually a 100. For this, up till here, I'll go and say, I know one thing for sure. Whatsoever mask I have up till root, whatsoever mask I have, for sure, whatsoever mask I have, one thing I know for sure that, okay, I can just modify at most one value. I can modify at most one value and still it should be a palindrome, right? So I'll go and ask him, bro, what if I modify you as, let's say I just say, because see, you know one thing that you can simply, if you had anything, let's say if you had, let me have a easy example. If you had 3, let's say no, let's say it has a ACA, right? You had a ACA, right? In this ACA, up till so far, now you know, because you are going back to root. You know one thing for sure, this ACA, if it needs to be a palindrome, so anything, if it needs to be a palindrome, if I just join one character in it, or basically saying if everything joins up, which means if I just have AC and C, which means AC and A will actually make a palindrome. So if I just have this and this as XORed, 101 XOR 100, it will actually give me a 001, saying the A is remaining. Why is remaining? Because you know one thing, AC and A cancelled out. What I did? Sorry, a C cancelled out. C, A, C, or basically A, C, C. You know, the C cancelled out. If I did a XOR with this, I know, okay, it is one node, because I know for node U, I need to find all the nodes V that I can go on from node U to node V such that it's a palindrome, right? So what I did was, I took a random node V, and I know one thing, U XOR V is actually giving me a 0, 0, 1, which is saying to me, hey bro, I have one bit as set only one bit as set in this entire representation. Only one bit is set. Just saying, okay, only one bit is set. And for sure in a palindrome, I know that I can have a palindrome in which I have only one odd frequency number. That is a here. Just saying, just doing a U XOR V is just showing me a number which is a 1, which is a 0, 0, 1, representing A having odd frequency, and only A. Other numbers are all 0. Just showing me A is the only number having the odd frequency. For sure, it can actually help me build a palindrome. Aryan, what if the frequency of all of them would have been 0? Yeah, that's also a palindrome. That's the condition, which means this UV will also have been a palindrome. This UV would have been a palindrome if this entire thing was actually a 0, which means I have no bit as set. If I had only one bit as set, still it's a palindrome, because for sure in a palindrome you can have one number as an odd frequency. But Aryan, what if I had 2 bits as set? No, it's not a palindrome now. So one thing you got to know for sure, that okay, if I have only one bit as set, so for sure it's a palindrome. Only one bit as set. But Aryan, what if I have no bit as set? Okay, cool. No bit as set. Which means like resulting as a 0, 0, 0 in the result after doing a XOR between U and V. If it is actually a result is looking like this, or the result is looking like a 0, 0, 0, 1, or a 0, 0, 1, 0, or the 0, 1, 0, 0, or 1, 0, 0, or so on and so forth. If the result is having only one bit set, still it's a palindrome. Now I got to know, okay, how I can identify from my bits, okay, my U comma V pair is a palindrome or not. But Aryan, again it went back to this concept, okay, for U I will go and have to check for all the V's. For 1 U, 1 E 5 V's. For 1 E 5 U's, again 1 E 5 V's. So that's a 1 E 10 V combinations. I can't do that. That's not possible. Can you think of something else? Yeah, we can. How? You saw one thing. For this U, which means this particular U, you were just checking a V to check if this V is valid or not. What I am saying is, for this U, what if you just assume this particular result? You assume this result. Aryan, how can I assume a result? Why not? You know that you have just 26 bits, right? And I showed you that your result will actually have either all the bits as a 0. When I say 26, it is actually 26 bits, right? Cool. Your result, it will have all the bits as 0, which I showed you here, all the bits as 0, or your result will have actually only one bit as set, which means all the bits as 0 and one bit as set. And then again, maybe the bit 2s, maybe the bit of b as this set, and then so on and so forth, but c is set. So I will have this 26 options. So in total, for this result thing, I have 27 options. So for this U, for this particular U, for the result, I will have only 27 options. That's it. So I will break my options into two parts. These 26 options, and this one option. Now, by this result, by this U, I will try to find the V instead. How? By simply saying, okay, 101 was a U. I just assumed my result, one of the result, I know I will try for all 26 options of result. One of the result saying it as a 001, right? Which is actually a result. And if I get something, let's say if I do a XOR, because I know ultimately the XOR is a reverse operation. Even if you do from U to V, how? if u XOR v is actually a result, then if I just do a XOR with result or XOR with v on both, or let's say I do a XOR with results. Okay, u XOR result, or let's say I do a XOR with v on both sides. So u XOR v is actually a result XOR v. So v cancelled. Cool. I'll do a XOR of result on both sides. U XOR result is equals to result XOR v. Result cancelled, so it will become v. So basically u XOR result is actually a v. That's simple XOR concept. So I know that u XOR result will actually give me a v. I'll simply get a 1 0 0, which is actually a v instead, right? So I'll just simply go and ask, hey bro, how many, or if there is some v or not like this. So I'll just go and ask him if you have some v like this or not. So I will get to know, okay, the v like this, let's say it just says me, okay, for this you also know one thing, you have to keep the count of all such v's, which means all such u's. So one thing also you know for sure, that you made these masks, good, but you also have to keep the count of all such masks, because for this particular u, what I did, okay, for this particular u, I tried to make a v. I will just go and count for this u what all count of such v's are there, which is actually a 1 0 0. It will just say me, okay, 1 0 0 v's are actually, let's say 4. So 4 I can make a uv pair. That's how I can know that with this u, I assume the result, and I can just assume this as 26 options, right? U, I will have 1e5 as n options for all the nodes. For all the nodes, I will have 26 options for the result, and also please make sure you have one option. And when I say one option of a 0 0 0, you will simply see that, okay, 1 0 1 or a 0 0 0, it actually gives me the same value as u. So it will actually again give me a u as 1 0 1. So if you have again getting a, if you assume the result as, let's say, 0 0 0 0 0, so your u will again become a 1 0 1, which is actually the same value. So you will go and find for this u, what all other same mask 1 0 1 u's are there. So for sure you will have to keep the track of all such 1 0 1. Let's say 1 0 1 entirely in my particular tree are, let's say 5. 1 is already here, so other 5 would be, let's say here, let's say here, or here. So I will just have, I can simply make a path to all of them, here, and here, which means I can make a path with 4 of them. 1 is already me, other 4 is actually all these u's. So it is nothing but for this u comma u pair, which means for this u pair, which means for this you assume, you just have the result as all zeros. You again got the result v as again the same thing. So for sure, while counting it out, you will have to reduce this particular u itself. But for such uv pairs, for this you assume this 26 results, 26 options, you get a v, you will have to go and count the v frequencies, what all 1 0 zeros I have in my array, and by this I will simply get, okay, for this all v's, which means for this v as 1 0 0, I have the frequency as 4, so I can make all such u comma v pair as 4 pairs with this u, with this v, with this particular result, with this result as a 1 0 0. I can make my 4 such pairs. I can just let you know that. With this, what you will do is you will go and try for all such results. Here it is next it will be a 0 0 1, next it will be a 0 1 0, next 1 0 0, and so on and so forth. So you know one thing for sure, you know it is u is nothing but n options you have for u. For this result you have 26 options and one option also for all zeros. I will have that in the end, because why in the end, matlab why separately, not in this 26 options, because the v will always be not equal to this particular u, because it is actually different. This v will be different, so I will just add the frequency of this v. But for this particular u and u both are same, so I have to reduce the frequency by 1 in counting in the number of pairs, right? Going in back, we have to also make sure that I have to make sure I will keep the frequency of all the mask out, because ultimately for a u I will need to know, okay, how many such v's are there. If there are, let's say, x number of v's, my x number of pairs will be there for this particular u. And for sure, you know what, ultimately for this V, again it will go and have the same mask and result. And so for this V, again it will go and find for this U. So a V for this, it will again for every V, which means you have 4 V's, again it will go and find a U. So again you will see that it is a repeating UV and VU pairs are repeating. So ultimately, please make sure that you divide by 2, as I showed you in the beginning also. And that's how you can simplify the problem. I hope that you guys got it. See, that was actually very straightforward. Nothing but a bit slide by slide upgradation of the problem. Let's do this. Let's try this. Let's try this. Let's try this, and so on and so forth. That's how you can solve this. Now let's quickly jump on the code. But yeah, before that, can we please smash that like baby to 125 likes? Just 3 more. That would be super great. And we actually see the code now. That's actually very easy. I'll quickly show the code also, and actually the logic also, which I explained. So actually make you understand. See, just that, okay, masking thing and a bit operation of a XOR and stuff. Let's skip the ad, skip. Yep. The operation of a XOR and stuff, it might be a bit tricky, but if you just write it down in pen and paper, that will actually be understandable, and it's actually much easier to understand by dry run from question number 3. Cool. Yeah, but before that, can we please smash that like baby to just 2 more likes? Just 2 more likes. Cool. Let's quickly see the code. Then after that, we will actually jump on to the, the chat, because my camera battery is about to die and I want to make it done before that. So yeah, let's quickly jump on to the code. So firstly, I will take the map. Now this, I'll show every map. You will see I will have one map, I will have one XR, and I will have the graph. For sure you have to make a graph. Cool. Let's quickly jump onto the code itself. Then we will see how everything is being used. It is my input, parent and a string, right? I'll simply make a graph out. I'll simply got the n, which is the size of my particular array. I initialize my graph because I know my tree is a graph, so I'm making a graph out. Just initializing my above variables, no use at all. I go on from I equal to 1 and not I equal to 0, because you remembered one thing, I equal to 0 is nothing but a -1 and nothing but a this character, which is not needed at all, right? So I know the actual starting of graph building is actually from the root itself. So I simply went on from I equal to 1, then went on. So my parent is nothing but my parent of I, but the actual node is actually a I. So I have to make a U to V connection. Right? I have to make this connection out. U to actually a V. Now you also remembered one thing, that in my tree I was just going on from root to actually these bottom nodes. Right? I was only concerned about root to bottom nodes. So I can simply make my U to V itself, and that is more than sufficient. I don't have to make a undirected graph. Although the graph is undirected, which means V to U combination you should also have been made. But you saw one thing. I was only going from root to actually the bottom to actually know what all elements are there, which means what all hashes or what all masks are for every such values. So for that, I just only want to go from top to bottom. I don't want to actually go back and iterate like this, like this. So I don't want to go back and iterate like this. So I just only want to go from top to bottom. So I just simply had it from U to V, which means from parent to check. Okay, cool. My graph is made. Now actually comes the task of my DFS. Now what my DFS has to do is, every time it encounters a character, please make the mask, resulting mask of that character, which means I'll show what it means. And then also make sure, keep on updating the frequency of that mask. Let's quickly see what I mean by that is by simply grabbing this example. Initially, let's quickly have the code. We reach onto this DFS. U is the node, mask is the initial mask which I have. You remember that initially the node is U is 0, mask is actually also a 0. I know I go on to next character, which is, let's say, a 1. So if I go on to it, and let's say you initialize by 1 itself, cool. You go on to it, you know that your new mask will actually become the previous mask plus what the character you encountered. you transform that character to actually the number, which is a 100, which means you will just left shift 1 by how many times? By 2 times, right? This is left shift by 1 by 2 times. So I know I will just get this C as a 100 by simply left shifting by 1 by 2 times. And how to know this 2 times? Simply doing a C minus A. Both characters minus C, I will just simply get the particular how many I have to shift. Then I will just shift this one by these times to get the mask of C. I will simply do a XOR of my upcoming root to actually this character to get the new mask, which is a 100, right? And that's how you will see. I'll just solve this problem. I'll firstly get this mask. I'll show you what it is being done here. No worries at all. But here you saw. I'll simply go on to all the child nodes of this particular root node. Then for this root node, I just grabbed how many left shifts I need to do. It is nothing but the character C minus character A. Just giving me, okay, what mask I have to make. I just make that mask as 100 for my character C. Earlier, my parent mask was actually a 000. So my new mask of this particular node, which I am at, which is a V node, for this V node, the mask is actually become a 100. Just saying, okay, it is the new mask of this particular node. And as I go on forward for this node, again, I will just go and make a mask of this A, which is actually a 001. I will simply do a XOR operation with the root node mask and my mask. I will get a 100 XOR 001, simply getting a 101. Simply saying root node mask XOR with my mask. How I made my mask? By simply getting the character minus A to get the how many left shift I have to do to reach to my mask, which is 100, right? I'll simply get this. I'll simply do a DFS going forward. Now, coming back, you will see that I also have to keep track of the frequency of every mask. You remembered that for this U, you remembered I will eventually get a V. For this U, I will eventually get a V. But for the V, I need to know what is the frequency of all such Vs. So for every mask, I need to maintain the frequency of that mask. So what I will do, I will simply use a map to just know what is the frequency of that mask. Okay, what is the frequency of this? What's 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 the frequency of this? Right? That's how I used a MP as a mask. MP as a map to know the frequency of every mask. Now, this particular XRU is nothing but saying I should also know that, okay, for this node 1, what is the mask like? So I'm just storing, okay, for a node 1, the mask is actually a 100. For a node 3, the mask is actually a 101. To actually know for every node from root to node, okay, I have just built this particular mask out and that is my mask. So I just stored two stuff. For every node, the mask which I formed on while doing a DFS, I just stored that particular mask, and also I just stored, okay, what is the frequency of every mask. And you remember why the frequency is required, because I ultimately for every U I will try to find the V out, and for V I will need to know the frequency of V ka mask for that frequency, because for that, okay, if for a U for choosing a result out of the 26 result, I have 26 result. I have 26 options. For choosing a U, choosing one such option, I get, let's say, V, and the count of, let's say, all such V's are, let's say, 4. So for this particular U, for this result, I have all these 4 V's. That is one such UV pair. Again, for this U, let's say for this particular result, I get again a different, let's say, 5 V's. So for this UV pair, it is again a 5 combination which I have. 4 combination from here, 5 from here. I simply keep on adding. It's just a UV pair which I can form, and this result will make sure that it's a valid UV pair. Valid, which means it's a palindromic UV pair. Cool. Now moving back, my DFS is done. I have my map having the frequency of all the masks. I have the XR which is having, okay, for every node, what is the mask like. Now coming in back, I will actually go and find my answer. How? Simply going on to every node, which means all of the n nodes. For every node, I will try on for the 26 results. Remember, I will try on for the 26 results. But Aryan, the result were actually 27. Yeah, true. The last result is actually I will try in here differently. So for this 26 results, I will go and try to build a V. So I will try to go and build the mask of my V by simply saying, okay, what all, what is the mask of this particular node I, which is actually node I. I'll get the mask of node I. It is this. What is the result? I'll simply say, okay, the result, I'll simply left shift it by, let's say, firstly by 0 time, 1 time, 2 time to get the result. It is my U, it is my V, it is my mask of U, it is my simply result, which is just the option which I'm trying for. I'll simply get the mask of V. Now I'll simply say, what is the frequency? Okay, my battery is dead. Let me jump in back. But yeah, before that, can we please smash the like baby to actually 130 likes, because today the stream has gone a bit long. Even the explanation itself. Damn. Cool. Hello. Am I audible? Yeah, am I audible? If yes, can we please let me know if I'm audible or not? That would be super great. I'll quickly switch back to my webcam. Yep. Am I audible? Firstly, if yes, then just let me know if everything is fine. But yeah, can you please smash that like baby for this hard question explanations? That would be super great, because later we'll be going on to actually the actual your doubts and stuff. I thought, like, I knew that my battery is going to be dead, but yeah, that's just for you guys. But yeah, quickly going on to what we are doing. We will simply have the frequency of mask of my all such V's. Because my map was storing the frequencies of every such mask, I simply have that in my answer. And for sure, it is just, I have tried the 26 possibilities. I still remember that one such possibility remain. What if it is the result, which is this particular stuff, is actually a 0 0 0. So you will simply get the mask as the same as XR of I. So I'll simply go and say my new mask here. If I see, if the XOR is actually a 0 0 0, so this mask will become a nothing but XR of I itself, right? If it is XR of I, I'll simply, as the same, I'll simply go and ask the map of XR of I. But you remember one thing, this XR of I mask, it's actually the U itself, it's actually the node itself. So just subtract a 1 for the node itself, else it will just become a UU, which means I know the mask for U, it is trying to search for other U's, right? For this U, it is trying to search for other U's. So my frequency of U, which is MP of U, when I say U, it's a mask of U, it is actually a 1 2 3 4 5 6. But all such pairs are actually a 5 pair from all to distinct U's, not me. Me to me is not a pair. So I'll just say, okay, just subtract a 1 for one such me to me pair. That I don't want, right? And simply having that in my answer. And for sure, you know that your U, V and V, U pair are repeated again and again. So simply do a by 2 to simply get the answer. And that's how you can simply solve this problem. I hope that you guys got it. If yes, can we please smash that like baby to 130, just 3 more likes, that would be great. And soon we will be ending the stream. I am done, super done. Because see, both the questions were actually very the question number 4 was logically very easy, considering just a bit manipulation stuff. It's very easy, not much back of the mind like required, just a pen, paper, that's pretty much it. Question 3 was actually very tricky logically to understand. The code was very easy. Question 4, logically understand, easy, but to code it a bit tricky. So yeah, that was for question number 2. And question number 3 and 4, we will quickly jump on to the comments, and probably we will be ending the stream soon. Cool. But yeah, before that, can we please smash that like baby to 130 likes, just two more. Quickly going on to the comments. Pranam Guruji, good. Sandeep sir, I request you to please explain a particular concept slowly. I noticed sometimes you used to stammer while speaking. Not correct, that is true. But yeah, that when to learn this bit masking is there in any playlist.
See, we have many questions of DP with bit masking where we have went on to super great detail of bit masking, and still knowing bit masking is nothing but just knowing the AND, OR and XOR operation. That's pretty much it. So yeah, that with that help, your bit masking will easily get covered. Just doing the questions about bit masking is more than sufficient. For this question, if you did it, please try it by yourself. Just manually on pen and paper, just do it by yourself, and by this you will simply get it covered. So that will actually help it. But yeah, just let me know. And for sure, if anyone watches it later, can we please have the timestamps in the comments? That would be super great. Right. Okay. Question 4 was definitely not made for me, Ritik. This problem is a combination of many concepts. True, bro, I'm able to build the logic whenever I see any problem. Can you see me? What should I do to overcome it? Unable. See, unable to build a logic, which means you are unable to connect the points, which means you have to start building to connect the points at the first go. So yeah, that will help a lot. Yes, clear. Thank you so much, Shreyash. Solve 2 questions, first and 2. Yeah, that is obvious and that is okay. But solving 1 and 2 in how much time, that is important. But solving 1 and 2 is actually okay, super okay. Because 3 and 4 was actually super tricky. So yeah, ending not understood. Ending on what part? This result part or this answer by 2 part? Bro, I was unable to build the logic. See, that is, see, when you but firstly, if these folks are newly joining in or watching in, can we please smash that like video to 135 likes if you have liked it? If yes, then please, because soon we will be ending the stream, because that is done for today. Cool. Yep. See, to build the logic and stuff, the best option is to actually start from starting. Just try to build slowly and slowly. Okay, if anything you are progressing in, just keep on going and keep on going and keep on going in, finding the loopholes in your problem, and just finding the solution for that loopholes was what the intuition is built on. If you are stuck at any point, just go and see, oh, for that loophole, what solution or what approach or what intuition we gave in. And then, okay, you have got the intuition, then start from scratch again from that intuition and start to build it from there itself. And that's how you can simply get it understood. Cool. I hope that you guys got it. Cool. See you guys in the next video. Until then, goodbye, take care, bye-bye. I'll simply have the water done. Before that, the folks are going in. Before going in, can we please smash that like baby to 135 likes? Just 3 more likes. That would be super great. Cool. Bye-bye. Goodbye. Tata. Thank you so much. I hope that you guys enjoyed today's contest and today's stream. Cool. Just a quick question. How many of you want today's Leetcode solution to come up? If yes, I will make it. If no, I am tired, I will just go and work on pop graph series and we'll just bring a lecture for that. If you want today's problem, just comment down below quickly, fat. Then probably I will think of maybe making it, because I am super hungry right now. Kuch nahi khaya subah se, so I need to eat something, and also probably will have to look for bar graph series. I also some things, how you check view and v part is palindrome, that for loop stuff I watch once again. Yeah, like you can just have it. Yes, you can just have it for sure. I will remember your name, that's for sure. But yeah, you can just watch it once again. That's, I'll just spoke it many times and very briefly, so that will be very helpful. But yeah, if the folks want today's lecture, just please let me know. If you guys want it, I'll probably bring it, else I will just skip it down, because it will again take kind of half an hour or so, 1 hour or so, 1.5 hours or so to actually bring it down. Find Leetcode, find the longest substring containing vowels in even counts. Whew. Okay, that is Nishant questions. But yeah, let's end the stream. Bye bye, tata, goodbye, see you. Do comment down below, and yeah, cool. Thank you so much for watching in. I hope that you guys got it. It's a 2.5 hour stream. Fuck. Bye bye. Thank you so much. But yeah, before going, can we please smash the like video with 35 likes? Just 3 more. 3 more. Bye bye. Cool. Tada. Ending the stream. Thank you so much.